Okay, so if we continue with the combination of the resistance, formula is very simple, and also if we apply on the circuit, so it is like not very much difficult concept. Just only important thing in this to identify the correct combination, because if you identify combination wrong, so definitely you will use wrong formula, so your answer will be completely different. So there are two combinations as we already discussed, series and parallel combination. So let's suppose if we first talk about resistors in series. So resistors in series means end-to-end connections. So definitely we have to connect resistors with one end to the second end of second resistor like this. So let's suppose if we have three resistors, so now we have three resistors connected with series in series combination with each other, R1, R2, R3. So basically if we talk about series combination and if you join with the battery, or let's suppose if we join all the resistors in a single circuit like this is resistor number 1, resistor number 2, resistor number 3. So in this concept you can see there are three resistors connected with the battery. So this combination is also called series, because they are again connected end to end with each other. So this is also called series combination. So in series combination, the current throughout the circuit remains the same, because charges it starts to flow from one point to another and they follow the single path. And when they follow the single path, it means the flow of charges remains the same, or the direction of the charges will also remains same. So electric current in series combination always remains the same, because they have only one direction to follow between two terminals. So current is same at all points in a series circuit. So this is the idea of electric current. And let's suppose if we have three resistors, so definitely we have three values of electric current. So the electric current through R1 is equals to I1, and that will be equals to current through second resistor, current through third resistor, and that will be equals to the total current passing through the circuit, right? And if we talk about the voltage, so definitely we know that when we are talking about the voltage, so voltage is like the difference of the potential between 2 points. So if we talk about the voltage over here, so voltage is derived among resistors and it depends upon the value of their resistance, right? Because if resistance is high, so definitely voltage will be greater over there. If resistance is low, so voltage will be less over there. So basically it depends upon the value of the resistance. So in this way they are connected with each other. And finally, if we want to find out the total potential difference, so that total potential difference will be equals to the EMF. It means the energy provided by the source. So sum of all potential difference is equal to the EMF. It means if we are using 9-volt battery, so that 9 volt will be divided according to the value of resistance between the resistors. So voltage will be equals to V1 plus V2 plus V3 is equals to the total voltage, right? And if we talk about the final idea of the resistance, so according to this series combination, the resistance will be equals to the sum of individual resistance. It means if we connect resistor in series combination, so we will get the greater value because we are going to add all the resistance. So for resistance, we can say, and for resistance, we also can use this concept like this, like we have 1 ohm, 2 ohm, 3 ohm resistor, and we have to make a large value resistance. So what we do, we just join them in series combination, so that will give you a large resistance as compared to their individual resistance. So the effective resistance means their total resistance when we combine them in series combination. So the effective resistance is the sum of resistance of each resistor right? So this is very simple idea of series combination, and it means that the total resistance or the effective resistance is equals to R1 plus R2 plus R3. So this is the idea of series combination. Okay. So let's suppose if you have resistors of small values and you have to make a large resistance. So definitely we will join them in series combination to get a greater value of resistance, right? And if we also consider the concept of the parallel combination, So resistances parallel combination are completely different with as compared to the series combination. So first of all, if we talk about the combination of the resistance, so we will join them like in series. It means same ends connected at the same side. So let's suppose these are the three resistors. So you can see their same ends are connected on one side. So this is the idea of parallel combination R1, R2, and R3. So basically when current starts to flow throughout the circuit, so let's suppose if current starts to flow from this direction, and when current reaches this junction or this branch, so what happens? Current starts to divide into two direction. Some of the value of current flows in forward direction, and some of the value of electric current flow in downward direction, and so on. It will divide in the forward directions also. So that's why in parallel combination, electric current will not remains the same, but voltage remains the same because all are connected in parallel combination. And we know that if we want to measure the voltage, so we can measure voltage by using connecting voltmeter in parallel combination. So if we talk about the voltage idea, the same potential difference provided to each resistor. So this time voltage will be equals to V1 is equals to V2 is equals to V3 is equals to the total resistance if they are connected in parallel combination, right? And secondly, if we talk about the value of electric current, so electric current divides in parallel combination, and this time when current divides between the resistors, so it also depends upon the value of their resistance, because we know resistance is like opposite to the electric current. So if there will be greater value of resistance, so definitely there will be less value of electric current. So larger resistors receives less value of electric current, and smaller ones receives more, and their sum of electric current I1 plus I2 plus I3 is equals to the value of electric current. And if we talk about the resistance, so basically in a resistance or in the final resistance of parallel combination, what we say, the effective resistance is equal to the sum of the reciprocal of individual resistance. And the final equation will be like 1 over RT is equals to 1 over R1 plus 1 over R2 plus 1 over R3. So this is the combination for parallel combination in resistance, right? So basically, we know that formulas are not difficult to understand. So we know that formulas are simple, but in questions, sometimes we have to identify uh, the connections by ourselves. So sometimes we make mistake over there. So that is important. Otherwise, question is not very difficult. Let's suppose if we consider a few questions related to the resistance.
Sir, can you go back to the formula 1 second? Okay, sir, thank you.
Okay. So basically, if we consider some questions related to the resistance, so in question number 46, when three identical resistors are connected in series, so their combined resistance is 6 ohm. It means their total resistance. So what is their combined resistance when they are connected in parallel combination? So when you join them in series, so their combined resistance is 6 ohm, and they are asking what is their combined resistance when they are connected in parallel. So basically, okay, first, if wants to add answer or somebody wants to explain. Okay, let's suppose if we consider in series combination that resistance 1 is equals to 2 ohms, second one is also equals to 2 ohms, third one is also equals to 2 ohms. So you
Is
will
it
get
option
answer.
B?
Okay,
Sir, is it A
okay, one
or
option
B?
A or B. So these are the two
It's B.
answers. Okay,
B.
okay. So basically
Sir,
we
B.
right. So you all know the right answer. That right answer is B, because if we join them in series combination, so it means we have three resistors of same resistance, let's suppose. So according to that, we can say in parallel combination, the parallel combination means that your resistance are equal to the sum of their reciprocals. So that's why we can say in parallel combination, your resistance will be divided. So that's why 2 ohm will be divided in three parts. So it will be equals to 2 by 3 ohms, right? And there are many questions like this. This is electron flow, potential divider. Okay, question number 37. A student joins three 6 ohm resistors as shown in the diagram. So we can see that there are 6 ohm, 3 resistors of 6 ohms connected in parallel. So what is the total resistance between points X and Y?
Is it C?
Okay, one,
I think it's B.
okay, B and C. So basically it is parallel combination, and in parallel combination we know voltage remains the same but current will divide.
Oh, wait, right, yeah, correct. Yeah. My
Yes, and we have to use the formula of parallel combination over here. So it will be equals to 1 over 6 plus 1 over 6 plus 1 over 6, and it will be equals to 3 over 6, or we can say 1 over 2. So 1 over 2 is the answer of the reciprocal, and if we cross multiply, so your total resistance is equals to 2 ohms, right? So in this way we can calculate for series or parallel combination whatever we want to calculate. Okay, so you can see there are many questions in MCQs that are linked with the combination of resistance. In theoretical question, we will start also that, but for theoretical, we first know about electrical energy, electrical power in the next class. Then we will continue with the questions, because then we are able to solve a complete proper question with electrical components. If we start right now, so you will find like we are able to solve half question. I know that most of you already studied this chapter, but still we have to work together. So in next class we will continue with electrical energy, electrical power, and after that we only left out in electricity with the concept of the fuse, the concept of the 3-pin plug, and yes, potential dividers. So these three topics we also have to work in practical electricity after completing electrical energy and electrical power concept, right?